Lord gives his people strength. The Lord blesses them with peace. From Psalms 29:11. I think this is an appropriate verse for this chapter, because if our endocrine system is not functioning properly, our bodies would not have the potential for strength as well as peace. If the endocrine system is not working properly, we can very quickly become weak as well as a nervous wreck. With having had endocrine issues, more stories to come in chapter 19, I can attest to that. But outside of the endocrine system, God still gives us peace and strength. So chapter 18 starts the endocrine system. And the endocrine system is a fascinating system. And I will probably say that the endocrine system is my favorite body system, along with the hematological system. All right, there's other ones that are interesting, but those two, I would say, really actually are my favorite systems. So the endocrine system has a lot of power over how our bodies function or don't function, for that matter. This system is responsible for the regulation of heat and metabolism. It helps regulate blood pressure. The system works through the production of hormones. These are chemical signals that are produced by a gland and then move throughout the body to a targeted receptor. The endocrine system works beginning as soon as conception, almost, via the mother's hormones. The endocrine system is necessary for all living functions, and below in the notes section you'll see is a bullet point list of how and why the endocrine system's hormones are important. All right, differentiation of the reproductive and central nervous systems in the fetus, stimulation of sequential growth and development during childhood and adolescence, coordination of male and female reproductive systems, maintenance of internal homeostasis, and as well as initiation of corrective and adaptive responses during an emergency. So here's a list of your objectives for chapter 18. It kind of looks long. My intention is not that it be long, but rather it be exhaustive in terms of, for exam 1, some of you thought that there was more detail expected of you than what was in the objectives. So here's a lot of detail to give you an idea of really exactly what I would like you to know. The first few, or 1 through 3, objectives 1 through 3, really have to work with a combination of just general information that's going to be at the beginning of chapter 18, as well as the Bozeman video, which was, 8 to 12 minutes in length. That again is pretty general in the material that it presents. So hopefully we all know, prior to getting into this class, that hormones control, or that there is hormone control throughout the body, and it's also regulated. And our bodies need to have properly functioning endocrine systems for the body to not only maintain homeostasis, but really to survive. And what you'll see here is a figure that looks at the hypothalamus working at the pituitary, which then works at the thyroid. So these are going to be endocrine glands. They have specific ranges and rhythms of secretion. The endocrine glands operate within feedback systems. And so that's what you see with these different plus and minuses and these different arrows here. Those are feedback mechanisms. And if it's a minus, then that means it's going to downplay or be a negative factor, which would stop the production of something or stop the activity. If it's a positive, then it's going to activate or initiate that system. All right, what we'll see on the next slide is that hormones have target cells, and those target cells are going to have specific receptors. And then hormones are also constantly excreted by the kidneys or are deactivated by the liver or different cellular mechanisms. So that is why our body system is constantly in this process of feedback loops, positive or negative, to make sure there is the proper amount of each specific hormone in the body at all times to allow for proper maintenance and metabolism and this whatever the physiological effect is going to be. All right, now, hormones can be regulated at the gland that they are produced by, but they can also be regulated at the receptor level. And that means that even though a gland might be producing a hormone via the positive and negative feedbacks that we saw on the previous slide, but also the target cell, even if the hormone is floating around in the system, right, in the body, if that target cell doesn't have the proper receptor, then that hormone is not going to have any effect. And in this top panel, we see upregulation, which means or shows that a hormone is going to come in and sit on the receptor of the target cell, and that response by the host cell or the target cell is going to cause the hormone receptor to be upregulated. And it's just a signal for the cell that it needs that hormone is available, so therefore it needs to upregulate the receptor. Down here you have downregulation. All right. There's a lot of hormone out in the system. It's filling up the receptors. And so that is going to tell the host cell that it actually doesn't need any more receptor. And then it's going to start to downregulate the receptor. And over time, you have only 2 copies in this cell versus 8 copies of the receptor on this cell. So that's probably not the actual number, but for visualization process, that's what it's showing. So if you think back to microbiology, what type of human cells does HIV infect? Hopefully you're thinking CD4 positive T cells, or that rings a bell now that I mentioned it. So CD4 positive T helper cells, and then some macrophages. Why? Because CD4 is the receptor for that HIV virion to attach to and get into that host cell. So the hormone is also going to be specific to that receptor, and so just not any hormone is going to bind any receptor. Also in your notes section, you have a couple of definitions, which 2 of which I know are review. You've got autocrine communication, which means it's auto, it's on the same cell. So if this were the case, if this was an autocrine communication, this hormone would have actually been secreted by this cell, popped it out into the environment, and it just looped around and bound to that receptor. Paracrine, that's going to be a very short distance in terms of this, maybe this cell here right next door produced the hormone, and the cell next door had the receptor. But then there is endocrine communication, and that's going to indicate remote cells, or remote communication. So if you remember about hormones, they have to move through the blood. So that makes sense where you have endocrine communication being distance. All right. Next is the hypothalamic pituitary axis. This figures from the 5th edition of your textbook, or the 5th edition of the textbook, and I just like it because it gives you a better idea of the intimate relationship between the hypothalamus, or we'll go over here, the hypothalamus and the pituitary, and the direct communication that those 2 glands have. So the hypothalamus contains special neurosecretory cells that's going to be facilitated or allow for that intimate relationship here. And then the pituitary is divided into two different parts, all right, both of which are very important. The posterior component of the pituitary, right here, that kind of has it's a minor component of the gland itself, has storage and releasing, or is a storage and releasing site for hormones, synthesized in the hypothalamus, so those can just simply travel directly down from the hypothalamus to the pituitary. And then the anterior is the major component of the pituitary, being about 75% of the weight. Now, the hypothalamic pituitary axis produces hormones that affect a number of diverse body functions, the thyroid, and adrenal and reproductive functions. These two glands are, as I already mentioned, intimately related. Initially, if a person is diagnosed with an endocrine issue that is focused at either the hypothalamus or the pituitary, without additional tests, it's actually hard to know if the problem lays with the hypothalamus or with the pituitary. Here you have figure 18.7, which shows that the pituitary hormones, those hormones produced by the pituitary, have a huge range of action throughout the body. The pituitary gland makes so many different hormones that go out to the rest of the body. A person would not be able to survive if they've lost their pituitary. However that might happen. We'll get into the specific types of hormones. All of these guys out here, some of these guys in here in the middle, and in Chapter 19. So unless it is part of Objective 3 that comes from the Bozeman Science video, at this point you're not going to from this slide, you're not going to be required to know the function of all these different hormones and the effect on the body system, but rather we'll talk about them as we move through the different systems. All right, the thyroid. Here's figure 18.11. The thyroid is a butterfly-shaped gland that sits on top of the trachea. The proper function of the thyroid is so important when it comes to metabolism and overall growth and maturation of tissue that this slide really does not do justice to its importance, doesn't do justice at all. The thyroid is controlled by TSH, or thyroid stimulating hormone, which is produced by the pituitary, which is made in response to thyroid releasing hormone, or TRH, secreted by the hypothalamus. And you'll see that, or you should see that in figure 18.2. In Chapter 19, we will discuss the different issues that occur when a thyroid is not functioning properly. And part of my intrigue with the endocrine system is that I no longer have a functioning thyroid because mine went out of whack, I don't know, about 18 years ago. Next we have the parathyroid glands. These are small glands located behind the thyroid gland, and their main job is to produce parathyroid hormone, or PTH. This is going to be a regulator of serum calcium, promotes absorption of calcium by the intestines, as well as metabolism of calcium and phosphate from the bone. So we'll get into looking at PTH a little bit more when we are in the muscular and skeletal system. And it also causes the kidney to reabsorb calcium and to secrete phosphate. And it's an antagonist of calcitonin. And calcitonin is there to decrease plasma calcium levels and phosphate levels. And this is where we will stop for part 1 of Chapter 18.